Okay, I think it's 1 o'clock Central Time. Welcome to our HDF Clinic, and let's jump right in. Someone left a question in our Google spreadsheet, which is great, which is always welcome and makes this interesting for everybody. Somebody is asking, are there or should there be special considerations when preserving HDF5 files for future use? The person supports a research data repository at the University of Michigan, and we occasionally receive these files, also NetCDF and HDF5 files created by MATLAB. Excellent question. I just, since I saw this question about half an hour ago, I started scribbling down a few things in the org file, and later I'll commit that, and then all the notes will be visible on this web page. But I have really sort of added a few things since I added sort of a couple of preliminary bullets. Well, the thing, and we should have a discussion if who asked that question is present here today, then we can sort of drill down a little bit on that. But from just reading the question, what comes to my mind would be sort of two broad categories of considerations. One is sort of a rather narrow HDF5 focused or centric view, which is to say, just for sanity, there are certain features in the HDF5 files that may or may not be present. And I think, so for me, if I were in a position like that, one of the criteria for archivability or suitability for archival, long-term archival of such data would be that certain features either be absent from that file, and I'll give an example in a moment, or if such features that create potential complications are present, then that they must be documented, and so whoever picks up these files in the future, that they are aware of certain assumptions of a certain context that must be there in order to reproduce the content of these files. And I give an example. So the concern is not so much with the files themselves and being able to read them in the future, because we as HDF Group, that's part of our mission, we give you this, what we call forward and backward compatibility. And we talked about that in one of the previous episodes, but just the gist of it is basically backward compatible, meaning whatever the version of the HDF5 library at that point in the future will be, we guarantee that that version can read all previously generated HDF5 files. It doesn't matter with which version in the past that HDF5 file was generated, or if it was generated by a third-party tool, we guarantee that you can always read things that were written previously. That's backward compatibility. Forward, we also talk about forward compatibility, although that may not apply here. But forward compatibility basically means that you can use an older version of the HDF5 library to access HDF5 files that were created past the release date of that specific version of the library. But this file that was created later does not contain features that were introduced later in the sort of software development and so forth. So an old version can read new files as long as that new file was created in a sort of more constrained setup. So that's forward and backward compatibility. So I think there are no concerns there. But I was saying earlier, it is possible in some HDF5 files that you can introduce dependencies, or you make assumptions about the context in which that HDF5 file occurs. So for example, in HDF5, we have that feature called external links. What that means is you can have an HDF5 file that refers to objects in other HDF5 files. And there are ways to express the location, so to speak, of these other HDF5 files relative to this file, the source file, let's call it that, or there is the possibility that you can put in there an absolute path names, an absolute path name. Now, from an archival perspective, my understanding would be that in the future, if not the relative location changes, then you're good. But these files get copied to a new file system where the base directory or the base location, whatever, is changed. And then such files would be problematic because the original assumptions about how to locate by embedding an absolute path in that HDF5 file, that assumption would no longer be valid. And then when the HDF5 library tries to locate that other object or these other objects, then that wouldn't work because the library would just say, I can't find this because there is no such file. So there are a few other features, and I take that question also as a good suggestion for us to maybe document potential traps and pitfalls for people who are in a position where they have to maintain these things, where we could say, well, in order to just make this whole arrangement more scalable, more stable and more durable, if possible, either avoid those features altogether, or if you then use them in a way where at least things are expressed relative in a certain constellation, rather than baking in and hard coding these absolute path names. Another concern could be dependencies on plugins. So some people, for example, use compression filters, and these compression filters, they are just shared libraries, DLLs in Windows and .so files, for example, in Linux or Unix. And the readability or the accessibility, in a way, of the data that was compressed or encoded or otherwise filtered with this external plugin, of course, depends on the availability of these shared libraries, would depend in the future also on the presence of these shared libraries. Now, there is no complication with the path because there is an environment variable that you can set where to look for these shared libraries. And as long as the ZFP or the gzip or the szip or whatever compression you use, for example, in the case of compression, as long as they are, and they typically are, backwards compatible, then there is no harm in the future in using a slightly improved version of gzip or deflate, is the correct nomenclature of the deflate algorithm, or the snappy, or whichever algorithm. But then definitely, if there is such a dependence, this dependence should be recorded somewhere, and so that not when people then retrieve these files, the library says, I can't read this data set, and for the simple reason that it's looking for a decompression filter or decoding filter or decryption filter that it otherwise can't get a hold of. So documenting these things up front and so forth, I think, goes a long way. And then also, I think archivists might be interested in also, people will typically maybe ask for entire collections, but then also ask maybe to do searches on these. And there, of course, it would help to have extracts, call them digests or catalogs or something, that facilitates this type of a faceted search, where people can just search for certain tags or names or values of attributes or something like that. But that, I guess, would be part of the whole ingest process when you accept a new batch of files into this archival environment. You would pre-process the data in a way to support those types of operations. And then I probably should have placed that in the other category, but certainly, I mean, at a minimum, you want to guarantee the integrity of these blobs in a way, these byte sequences. You can just take some kind of hash like a SHA-256 or some kind of checksum, so that in the future, when somebody accesses that one of these files, that you can ensure that, yeah, it's a byte for byte identical copy of what was originally placed into the archive. So those would be the top things that come to my mind, not having thought about it for a long time. But if the person is here, maybe he or she wants to respond or ask more questions.
I am here, actually.
Okay, great.
Thank you for taking this question. We do get a fair amount of these hierarchical data formats. Some of them are specifically HDF5, and as I indicated, some are netcdf or whatever, but it's helpful to know that there can be things like relative paths and whatnot. And when you're talking about faceted search catalog, are you talking about maybe searching within the file?
Yes.
Okay.
Yes.
So are there, I know that with some of these things, like with the FITS file format for astronomy, there are headers that are fully informative, and with netcdf, there's a lot of information in the header there. With a regular HDF file, there's also header information that could be scraped as well.
Yes.
Okay.
I wouldn't call it exactly header information, but what you could do is, for example, you could dump an ASCII version of the hierarchy, so to speak. There's a command, and I can add this to the notes.
That would be great.
Like H5 dump with some options depending on how extensive you want that information to be. But then, yeah, once you have sort of call them the variable names, let's say you have one of these files where velocity or some other physical quantity was reported, and just to report the presence of that quantity in that file that might be absent in maybe some other files in that collection, or if you want to go beyond that, as part of the pre-processing, you could, for example, extract simple statistics like min and max and average or something like that. If somebody says, well, I want to look at that file only if the salinity
if it's in this range, right?
Yeah.
Okay. Yeah. All right. Well, that's good to know.
Yeah. So that's definitely possible. And it really depends, and that's where the domain experts sort of come in. And I'm sure it's like pulling teeth. It's like getting good with for software design, is ask a researcher and say, well, what do you think someone coming back in 10 years looking at this collection, how would they decide whether this data is relevant or of interest to them? And that's a tough question, I understand that, but still, given what that mission was for, that campaign, that experiment, and so forth, what is common scientific practice today to document that? I think that's what it comes down to. Right.
Yeah, but it's helpful to know. I mean, I'm primarily the one at our university that looks at these files from the standpoint of the library, and it's just kind of good to know each one of these, all files have different places to look for information or different ways to get this sort of meta information out of them. So yeah, if you've got a simple code or whatever, to run for that would be perfect.
Right. And I know from other projects, of course, there are more sophisticated efforts. For example, with the whole sort of semantic web movement and so forth, people started sort of creating ontologies and so forth. So if for the specific domain such an ontology exists, it would certainly be great to
tie into that
or relate exactly to this. And I know we work, for example, with a consortium in sort of the pharmaceutical industry, and they have, as far to my knowledge, gone the farthest in terms of that they have mandated that the data, the metadata be expressed in these triplets in representation, and they use ontologies because they don't want to fix a specific metadata model. They kind of want to keep it open so that it can evolve with the instruments and the changes in the disciplines. And so there are also efforts like that. But then the question is also, how valuable, what's the potential value of that data in the future, which is, again, hard to say.
It is hard to say, yeah. But I mean, I think you're exactly right. I think if we could pull out some of this information, maybe save it as an ASCII file alongside of this, so that for searching or scraping or whatever, or make it available in our Solr search index or whatever, then it would not necessarily future-proof it, but it would make it a little bit less of a black box than what it is right now, you know?
Yeah, and I'm going to take that as an action item. I can't promise anything.
That's okay.
From our perspective as HDF Group, we should definitely have at least a page or some general guidance, at least from our perspective, from the HDF perspective, what we recommend, what we in the past we have spoken, for example, if you take another binary format like PDF, for example, there is a standard called PDF-A, PDF-/A, which is sort of a subset of the PDF standard in terms of features, but these PDF-A conformant documents are considered to be archivable, meeting whatever the criteria are for a PDF document to be archivable. And so they have gone through this effort and said, hey, if you are a government or a large organization or something like that, and you want to invest into long-term archival of your internal communications and specification and whatnot, and PDF is your format of choice, then follow this guidance and make it PDF-A, because then it will be compatible with all kinds of things, and people in the future will have less trouble to make sense of what happened. And
yes, that, you know, guidance would be great. I'm not going to hold you to it, but you know,
yeah,
anything along those lines would be fantastic. But I appreciate what you've shared thus far.
Okay, thanks. Yeah, no, that makes it interesting. Otherwise, we just talk about geeky stuff here.
Right.
It's good to see that HDF is being used in all kinds of different contexts. And,
yes, yeah. In fact, I was just talking to a researcher the other day. They said, well, can you take HDF files? I said, well, yes, we can. Well, you know, so whatever. So yes, we do get these requests from time to time. So it's just good to know how to, you know, what to think about when one comes in.
Okay, good. Well, thanks for the question. I'll switch then, just unless there's another question, let me pause and see. Nobody has added a question here, but maybe somebody who is online has another question. Otherwise, I'll just move on with our usual routine. Okay, I'll do that for now. So last week's highlights, there was one interesting announcement. A member of the community actually implemented a new filter plugin, speaking of filter plugins, a compression plugin based on Google Snappy. But the twist, or the interesting aspect of that is actually this runs on a GPU. So Lucas, otherwise also known as Mr. HDF5 UDF, user-defined functions, implemented this, or he used someone's implementation for CUDA, so that's NVIDIA's graphics programming API, and that's very interesting work, and I have it linked here, so if you want to follow up on that. Snappy is sort of, yeah, that was sort of in the days of sort of the big data serialization formats. There were all kinds of different compression methods bandied around, and of course there is always a trade-off between compression speed and compression ratio, and I think Snappy is sort of, yeah, it's snappy, but it typically doesn't compress as well as some of the more costly methods. And but still, I think it's a great contribution, and definitely GPU-based compression and decompression is a hot topic these days. Then there was another interesting forum post, and basically the user described the following problem. He said they are storing large one-dimensional data sets across multiple HDF5 files, and they receive sort of compressed chunks from some kind of instrument, detector, camera, or something. He wasn't specific there, and that's also not necessary, where on each chunk they have sort of a fixed number of samples and compress these just to save some space. And of course, a use case like that, if you want the best write performance, you use direct chunk writing. So you can write the chunks bypassing the filter pipeline directly into the HDF5 file, and you get write performance. You get good write performance. However, the problem that the person pointed out was that in some cases, the chunks that they receive from this instrument contain samples that, in a way, since everything seems to be time ordered, sometimes these, he called them, or she called them, boundary chunks, that there are some samples that belong to one timestamp or to one epoch, and then there are some samples in the same chunk that belong to the other epoch. And the person asking the question was asking whether how to deal with that, how to make sure that the right information gets into the right place. And a suboptimal solution is to basically take that chunk as it arrives, that compressed chunk, decompress it, take it pretty much apart, sort of separate the by timestamp the samples that belong to the previous timestamp and the ones that belong to the next timestamp. And then, of course, on the past side of things, there is no problem because you can have what we call an edge chunk, no problem there. It doesn't fill up the full nominal chunk. Whereas you have a little bit of a problem in the next time step, because you will then have that initial region, since it's one-dimensional range of that chunk, that you either have to mask out somehow with some fill values or something like that. But that's, of course, a lot of overhead. And you might say, well, is there a better way to do this? And it's always great to get questions like this, because that gives me a nice segue into sort of talking about something that offers a better solution, I believe, number one, but also goes toward, we are all here to learn, so to just highlight this or that feature of HDF5 that you either may not have heard of, or you heard about it, but it wasn't exactly clear what it was about. And this is what we call virtual data sets. And it sounds pretty complicated, but it's actually not that complicated. Okay, so taking a step back, data sets, we all understand that very well, or in NetCDF, they are called variables. And every such variable or data set has basically a shape. And you can, some people call this rank. It's an n-dimensional, multi-dimensional array, rank or dimensionality, and it has an element type. So since it's a dense array, rectilinear, each cell, if you wish, is populated with an element that has a certain type, integer, float, or something more complex. And that's a logical thing. The variable, the data set, and so forth, it has a shape and an element type. Now, physically, when we put this into an HDF5 file, there are variations of layout. That's what we call layout. And the layout could be contiguous, which means that this logical shape of elements this grid, if you wish, is just there's a certain order and C, it's row by row, or that's the slowest dimension in this multi-dimensional array. We pretty much visit all these points and contiguously lay them out in the file like that. And that's what's called contiguous layout. Now, there are other layouts. So for example, there's chunked or tiled layout where rather than storing this whole multi-dimensional array as one contiguous piece, we break it up into even-sized chunks. And then these chunks give us the flexibility that we can put them pretty much anywhere in the file and not known to the user, but it just makes allocation more efficient. And you can have, for example, infinite or indefinite dimensions where if you can just keep appending data, you don't have to know a priori how large a particular extent is. Or if it's very small, we have something called compact, or, and that's the fourth thing, it can have virtual layout. So rather when we say a virtual data set, it's not so much the data set that's virtual, it's the layout that's virtual. Now, in a somewhat circuitous way, you could say a virtual data set is an HDF5 data set of virtual layout. Well, what is virtual layout? Virtual layout basically means that if we have that data set, the elements are not necessarily stored in that data set in question, but rather they can be in, call them constituent data sets, and these constituent data sets can reside in the same HDF5 file or in other HDF5 files. And not to confuse you, but it's possible that the constituent data sets of that virtual data sets in turn are actually also virtual data sets, but that's, you can ignore that for now. That doesn't really complicate matters much, but it's possible. Okay, so it just means virtual layout basically means is I can construct a data set, but the physical data, the elements of that data set can be sort of pieced together, aggregated from subsets of other data sets elsewhere. And coming back to the earlier question, that's exactly such a situation where, yes, you have to somehow describe where you source that other data, these other elements. And that's where sometimes you are inclined to introduce absolute file paths and so forth, which from an archival perspective is poison or is not a good idea. And you can use relative paths and then everything is fine. But if you use absolute paths, then that's maybe not so helpful. Now, how do you construct these virtual data sets? Well, basically, you have to describe how the elements from these constituent data sets map into sort of slots of that virtual data set that you are constructing. And there is one function in the HDF5C API that makes that happen. It's this function called H5P Set Virtual, and its primary argument is a creation property, because remember, when you create a data set, you can influence the layout of that data set through the creation property list of that data set. So in this case, you would prepare the creation property list for that virtual data set to be. And as we said, that virtual data set to be will have a shape. So you can describe that abstractly. And then you describe how the selections, it doesn't have to be whole data sets sourced from somewhere else. It could be just selections on those data sets, but you are basically listing by calling repeatedly H5P Set Virtual, you are saying, okay, here's a piece that maps there in my virtual data space. Here's a piece from another data set that maps over there. And you just piece it together. And then once you're done, you're basically creating that data set, and you have a data set that you can access, you can read, write from. It will feel like a normal, in double quotes, HDF5 data set. It's really just a piece of metadata, and the HDF5 library under the covers will sort of direct your calls to the right places. There's a little bit of a simplification here. For example, if you have infinitely many potentially or indefinitely many files involved in such a virtual data set, that's possible. You can use sort of printf style format strings to describe the enumeration. And since we are a little short on time, I'll just be quick, but you can also read the, I replied to the user in the forum, and there's a little bit of discussion right now. The big question is, well, how does that help with this use case, with this question here? Well, it helps that you can basically do one of two things. You can take that boundary chunk, that chunk that contains samples that sort of go either way, and you can either write it to both data sets, or you can just decide which one you want to write it to. But in any event, you can then define one or two, or however many you like, virtual data sets that make reference to these, call them physical data sets, or data sets that contain constituent data sets, I called them earlier. And you can sort of do that separation virtually. You don't have to decompress the chunk initially and separate the data set elements. You can achieve that same effect through virtual data sets. And basically, there are two implications that you want to be aware of. One is, if you repeat data, there's always a coherence problem, which means that if your data is read-only, your good repetition might actually give you better performance because you have multiple data access paths. However, if you think about updating data, then there's a problem because you have two or more copies of the same value, and then the responsibility is on you to make sure that these copies get updated accordingly. In the other case, when you just have a decision that says, I'm going to give that boundary chunk either to the previous or to the next data set, there is no coherence problem because there is no duplication. However, then when it comes time to read that data or even write that data, the HDF5 library would have to open two files. I'm not saying that this is a tremendous performance overhead or burden, but from a conceptual point of view, it's less self-contained. If you replicate it, then you are accessing only one file. But if you do that kind of coherent approach, then the HDF5 library has to do sort of an extra hop to resolve that. I listed here the RSC just to learn more about virtual data sets in general. Has any detail with some limitations, a great source of examples and use cases. And I can also tell you that H5P, the Python interface for HDF5, has a great interface for virtual data sets. If you want to try something out, or if you have problems, just ask a question and we come back next week, and I'm happy to prepare an example and show you how to create virtual data sets. And I'm afraid that's all we have time for today. And thanks for coming. Come back next week and we will answer more questions and get into other topics. Thank you.